Hello and welcome to the webcast titled Aerospace Cybersecurity Strategy, Building Resilient Embedded Systems at Mission Speed. My name is John McHale, Editorial Director with Military Embedded Systems, the SOSA Special Edition, and the FACE Special Edition. I'm also moderator for today's event. To learn more about military embedded systems, please visit militaryembedded.com and check out our articles, blogs, and podcasts on military technology. Modern aerospace platforms, from crewed aircraft to satellites and unmanned aerial vehicles, face a rapidly evolving threat landscape. As cyber threats become more advanced and supply chain scrutiny intensifies, traditional safety-focused engineering must expand to include built-in cyber resilience. In this webcast, Shane Fry, Chief Technology Officer with RunSafe Security, and Patrick Miller, Product Manager with Lynx, will demonstrate how to proactively defend against memory corruption, secure operating environments, and generate actionable vulnerability management, even in systems with limited compute and connectivity. This event is sponsored by RunSafe Security and Lynx and hosted by Military Embedded Systems Online and Open Systems Media. Now, before we get started, I've got some housekeeping items for you. This and all Open Systems Media webcasts are copyrighted and may not be recorded or used in any way without the express written consent of Open Systems Media. This webcast will consume about 40 to 45 minutes, leaving the remaining time for the question and answer session. Now let's take a little tour of the viewing console. You'll find on your right-hand side an area where you can enter your questions in real time. And we encourage you to ask these questions throughout the event while it's fresh in your mind. And we'll address as many as we can during the closing Q&A portion. If you have a question for a specific speaker, please note so at the beginning of your question, I will offer it up to both of our experts. If you have a question pertaining to the event operation itself, one of our technicians will get back to you during the webcast. And please note, as much as we'd like to, we may not get to all of your questions today. In that case, someone may get back to you after the webcast with more information. Now, on the other side of your screen, on the left-hand side, there's a resources section. And that's where you can find today's slides and speaker information. And there's two more features that we're excited about with our platform. Your console is now customizable insofar as you can manipulate all of these widgets, Q&A, resources, and presenters to view in an ideal experience. Expand them to get a closer look or close them to have the presentation window automatically resize around them. For maximum screen size, close them all or use the full screen control in the upper right-hand corner of the presentation window. To bring them all back, simply click on the buttons in the bottom middle dock. In an effort to make our webcast more accessible, we have also added closed captioning capabilities in nearly a dozen languages. To enable this functionality, simply click on CC in the upper right-hand corner of the presentation window and select your language of choice from the drop-down menu. This webcast will be archived online at the same URL used to join today's live session and be available within 48 hours. Once up, it'll be available for at least 1 year. Now, Shane will start us off by talking about cybersecurity threats in aerospace with a focus on aerospace software. Shane? Shane, you're on mute.
Oh, man. It's a bad start to the webinar. So as everybody here is aware, the cybersecurity landscape for aerospace systems and capabilities is rapidly changing. Maybe not as much as we'd like to see in the military space, but there's definitely a lot of really great work happening. And RunSafe and Lynx are kind of core to a lot of those efforts today. And so, to kind of set the scene for the rest of the discussion today, we wanted to talk about what's the cybersecurity landscape look like. There's a lot of ways to look at cybersecurity for aerospace and defense, but we're going to really look at kind of the end systems themselves and how attackers can look at that and take advantage of those systems. So for your primary attack vectors, we're seeing a lot of interest in supply chain infiltration. So that's commercial off-the-shelf solutions that are maybe dual-purposed for commercial and aerospace systems, and that can also include open source software. And we'll talk about that a little bit as well, where open source can help accelerate time to market and time to fielded systems, but they can bring along risk as well and vulnerabilities that can be exploited. The other thing that we see a lot of is state-sponsored targeting. That's kind of obvious, right? Various nation states care to take out weapon systems of other nations. But what's important about the fact that this is state-sponsored is we don't see a lot of cyber criminals targeting aerospace systems. They're not going to extract a lot of money from the U.S. government or other governments for that. So state-sponsored targeting carries different tactics and procedures and sophistication levels. But as we look at what's all out there in aerospace systems, a lot of the attack vector is through memory corruption or memory safety vulnerabilities. So, Microsoft and Google have said over the years, anywhere from 40 to 70% of vulnerabilities are those memory safety or memory corruption vulnerabilities. As we look at aerospace systems, that's going to trend towards that higher 70%. And there's kind of two reasons for that. One, you don't see a lot of airplanes flying around with web servers and SQL databases where you can have web-based attacks. And then you have things like 853 requirements for ATO, where you've got to resolve a lot of these things like hard-coded passwords and poor configuration issues. And while that process isn't foolproof, it does tend to drive out a lot of those kind of easier to resolve vulnerabilities. And so, that's the attack surface or the attack vectors. But what are things that are being targeted? Satellite C2 and ground stations, UAVs, everything from big systems to drones that we're seeing in kind of the Ukraine and Russia conflict that could just be commercial drones, but those are now good targets for attackers to prevent missions from being successful, as well as aircraft avionics and military ground systems. And so I mentioned earlier commercial software and open source software. Part of the challenge is, how do you secure everything, all of your proprietary and your vendor software, your commercial stuff, your open source? And in a lot of cases in aerospace, you're talking about software that's been developed for 10, 15, 20, 30 years or longer. So back in those days, that software was maybe designed to not be connected to anything. But now we're seeing more interconnectivity and more viability to attack those architectures and those softwares that weren't previously connected. But also, as we look towards government guidance to rewrite code in memory safe languages, that's a multi-trillion-dollar exercise for the software industry. And so that's a huge cost that we can't just easily do or quickly do. So how do we look at software security in aerospace and get systems that are secured, but that have a lot of legacy code in them?
Okay, and that brings us. Could we start the poll?
Yep.
Okay, the poll. We're gonna have a poll for you right now. What's your biggest vulnerability? Your biggest challenging in managing embedded systems vulnerabilities? Too many false positives. B, slow patch and update cycles. C, research and budget constraints. D, lack of software supply chain visibility. E, compliance pressures. F, other. Please share in the chat. Now I'm going to give you all a few seconds to fill it out, and then I'll tell you who's leading before we get to the next slide. Well, no surprise there. Research and budget constraints seem to be the leading challenge. It always comes down to money, but a close second is slow patch and update cycles. So now let's move on to the next part that we have here. And we understand that embedded systems are at risk. Patrick, can you take us through the strategies for building resiliency into embedded software?
Of course. Thanks, John. So when you look at integrating cyber resilience into your platform and program, you need to start at the foundation. Particularly when you're talking about, as Shane mentioned, legacy code that's been out there for many years or decades, transitioning from a safety-centric design into an integrated cyber resilient design will require that security be embedded at the architecture level all the way through to the deployment and not bolted on later. And so seeing with Lynx secure separation hypervisor kernel, Lynx secure kernel hypervisor, we're able to ensure that immutable hardware partitioning that's isolating the virtual machines or subjects with the strict isolation and least privilege design principles. So you have that mission assurance from the beginning. And when you then look at taking the mixed criticality systems, which we're seeing a lot more and more of, particularly in the uncrewed systems, while still maintaining the real-time security for the safety critical elements, you need a platform that's able to manage those two workloads side by side in parallel on the systems, so that whether it's avionics, satellites, other payloads, ground control systems, anything with partitioning for safety critical and non-safety critical, but still with that focus on security as you have more connectivity to those embedded systems. That's where Mosaic comes in with its looking forward into the future with the modular upgrades capabilities, because you're able to reuse different software components and build from the ground up that architecture and model-driven design for your configurations. And so that translates then forward into the runtime risk mitigation for these constrained environments where you have a lightweight hypervisor with a minimal attack surface. Separates you from preventing the runtime privilege escalation exploits, and the separation kernels in the hypervisor, along with the memory reallocation, the randomization. You are able to take advantage of that no performance trade-offs with the security enforced at boot and runtime.
And Patrick, as you see, systems moving over to the Lynx capability, I mean, it feels like there's a lot of value in being able to kind of rehost rapidly into a secure, more resilient architecture, just kind of out of the box with Lynx. I mean, can you talk a little bit about how customers are doing that today?
Yes. So the question is, how are they taking their Lynx out of the box and running their different applications and operating systems from day one in the environments?
Yep.
And so we'll get to that, our case study later, but what we're able to do with the separation kernel hypervisor is at the bare metal or metal level, it manages that virtualization strategy. And so you have the Lynx operating system, whether it's the Lynx OS 178 or Lynx Element. It's more of a unikernel design. You're able to then package that application, drop it right in as though it was any other operating system, and go from development straight through to deployment with that commerciality in mind, where you have that commercial off-the-shelf capability.
Okay, and now we've got a poll for you. How confident are you in your visibility into your software supply chain? A, very confident. B, somewhat confident. C, not confident at all. Or D, unsure, needs improvement. Now I'll give you maybe half a minute here to kind of throw us some answers at us. Looks like the leading answer is somewhat confident. So now we will get to our next part. And so we've discussed strategies for making embedded systems more resilient, but what about vulnerability management? What are the challenges there and some approaches to addressing them? Shane, can you take us through that?
Yeah, absolutely. So interesting results, actually, on that poll question. I think, somewhat confident leading the charge is great. When we talk to a lot of folks in the commercial space, excuse me, we get a lot more not confident at all, which is, kind of an interesting dichotomy there. But part of building secure systems and resilient systems is understanding software through your supply chain. And so, there's a lot of tooling out there for doing static analysis and dynamic analysis and, those are requirements for getting ATO, and that's great. But if we look at the efficacy of those tools, there was a study out of North Carolina State University a few years back. They found that static code scanning tools only find 2.5% of all identified vulnerabilities in software. And that's 2.5, which is crazy. We had to double check the math. That seemed crazy, but it tells a really interesting story about how much effort systems designers and implementers are spending doing SAS scanning, only to not find the majority of the vulnerabilities through that methodology. And so, we really have to think about a lot of things. I mean, that SAS capability is really just looking for unknown vulnerabilities. But when we look at the full picture, your software has a huge supply chain associated with it. And that's going to be through your vendors, and not just my vendor XYZ provides me software, but they have software all the way down their supply chain. Same with your commercial off the shelf and your open source software. And so a key aspect of building a secure system end to end is not just your runtime configuration that you see with like NIST 853, but also looking at what are the known vulnerabilities in your supply chain. And on the unknown side of things, how can you predict and mitigate risk to unknown vulnerabilities? So you've got to look at that as well. And so that's where, a couple different things kind of come together to help you build a secure system. The first is having a good, accurate, and complete software bill of materials. And if you're doing web development, if you're doing Python or Rust, building an SBOM is really straightforward, right? The built-in tooling does a great job at getting you information about all the software there. A lot of the package managed ecosystems today even have abilities to just query them for vulnerabilities in the software that you're shipping. And that's great. But as we look at embedded systems, as we look at aerospace and military systems, a lot of that's in embedded code. It's C, it's C++. We see a little bit of Rust now, but not a ton, especially not in safety certified systems. We see, Ada and Fortran and, hand coded assembly. And so you need a good software bill of materials for that. And there's really kind of three philosophies around software bill of materials. There's source-based SBOMs, binary-based SBOMs, and build time SBOMs. Binary-based SBOMs, you can take in software from a vendor, something you've already built, do an SBOM. And those solutions can give you some good visibility, but they're also going to create a lot of false positives and false negatives because they're going to just guess at what's in your software. If you look at source-based SBOMs, those are going to look at just the source repository that you have today, and you might get inaccurate information out of that because you're pulling information at build time for a new version of software. Or you may have 3 or 4 different implementations of a encryption library, for example, depending on whether you're building your military target or your commercial target, or if you're building for one architecture or another. And so you might end up triaging a bunch of extra vulnerabilities that actually aren't shipped in the software that you're shipping. And so RunSafe really likes build time SBOMs because you can see what goes into your software when you build it. And that's really the best time to know what goes into your software is when you're building it. And so having a good build time SBOM is going to give you great visibility into the known vulnerabilities in your supply chain. Now, a lot of folks are going to say, well, but I have vendors and I've got commercial software. How do I get a build time SBOM from them? And the answer is make that a requirement. Have your vendors provide you build time SBOMs, not binary or source. And so you can get a complete view through the entire supply chain that you've got. And build time SBOMs don't have to be any more complex or hard to integrate than a source-based or binary-based solution. So once you've got that kind of software bill of materials, that's going to help you understand the known vulnerabilities in your software. The next thing you want to look at is a risk-based prioritization of those vulnerabilities. And a lot of people already know about this, looking at severity levels for CVSS, vendor advisories, things like that, prioritize your criticals, your highs, Look at mediums and lows when you got time. But another way you can look at this is to say, well, what if we don't know about all the vulnerabilities in our software? How do we categorize the unknown? And that's where we can go in and say, let's look at what attackers can do on a system if they were able to find these vulnerabilities, and prioritize not just by vulnerability, but by which components in our ecosystem should we be prioritizing doing better security or better code reviews or scanning or things like that. So once you've got an idea of kind of your known and your unknown, you want to feed those known or that SBOM through a vulnerability management capability to get you kind of a good view of all the vulnerabilities that are present. And that really should be a multi-source capability. NIST and NVD provide good data, but there's a lot of other systems out there that have different data sets than what NIST and NVD do. And so you want to be able to use kind of a vast array of sources for that to get you the most accurate information about those vulnerabilities. And then, as we look at aerospace systems and weapon systems in general, we understand that you can't just push a patch in 5 minutes once you've fixed a vulnerability, right? It might take weeks or months or even years to get a system back in. And so, where you can, you should deploy runtime exploit prevention capabilities that will allow you to get protection against vulnerabilities you know about today, as well as vulnerabilities that you find out about tomorrow or a year from now. And that gives you kind of a complete picture of building the most secure thing you can with the least amount of risk for what you ship to customers or to the field, and then giving kind of the system itself the ability to protect itself in the field should new vulnerabilities be discovered.
Okay, and that brings us to our next poll. How much emphasis do you place on software safety versus security? A, mostly safe, security is secondary, e.g. safety certification drives all decisions. B, mostly security, safety is important, but secondary, e.g. protecting against cyber threats is the top priority. Or C, balanced 50-50, we try to treat them equally in development and operations. D, depends on the project, different platforms or programs tilt one way or the other. Or E, not sure, still figuring out priorities. So I'll give you guys about 20, 30 seconds to answer the question. It looks like the leading answer is A, mostly safety. Security is secondary. And with that, we're going to move on to our next section. One of the hurdles in aerospace and defense is compliance and tough certification requirements. Patrick, how can security be better brought into these efforts?
So, thank you, John. The way the Lynx approach to accelerating certification and compliance is, again, by making it part of the architecture and not a afterthought once you have the operating system, the hypervisor, and ensuring that those components are certifiable from the beginning so that you have you're able to then accelerate your timeline to certification. And so with that certification is oftentimes takes years and many dollars to get to that final state. You're able to get it in your platform, and that's why oftentimes we see these software systems in aircraft or other deployments for many years after that, because they're so expensive to get there. And so by taking a model-driven approach with reusable software components or model-driven design, we're able to condense that and compress that certification timeline. It depends on the project, but whether it's for the DO 178 up through to LA, we're able to then compress that so that you're spending more time on developing your applications and your needs and focusing on what you or the customer needs. You're able to then improve that ability to get through that certification milestones. And so whether that's integrating all sorts of different tools within the Mosaic platform, from the SBOM generation to the code analysis, and other tools to shift left as much of that testing and early validation as you can, and reduce the rework, particularly as you go through those update processes and patches that we just talked about around vulnerabilities and so forth, particularly with the connectivity and speed at which we're able to and also forced to develop these systems. And so again, it's just the focus on the end goal of a faster time to field the capability. We're seeing that in the world today, that these systems need to be ready yesterday oftentimes. And so having those certifiable components that are built on that model-driven design are able to reuse those across other programs and just accelerate that certification and development process and cycles. So in that way, you're able to then take both your safety critical items and your security focused items and pair them together, and not have to have a 1 or 0 choice between the two.
Okay, so now let's talk about real world. We've talked about these safety and security topics throughout, we've gone into detail, but so far, are any of them being put into practice today? Who'd like to go first, Patrick or Shane?
I'll let Patrick
Sure.
go first.
Okay. Yes, John, that's in part what brought this webinar together was a shared customer between Lynx and RunSafe had the need for memory protection in their deployed embedded system, but they also had strict size and weight power constraints around that compute architecture. And so for them, going out to take various endpoint security solutions, other ones out on the market, were too resource intensive or too incompatible with the real-time embedded system that they were working with. And so Lynx and RunSafe, obviously, we paired together our capabilities to provide them the capabilities around minimizing the hypervisor footprint and taking advantage of the RunSafe capabilities. And so from there, what we did hand in hand between Lynx and RunSafe and the customer, we were able to create that deployment capability that protected against everything from the memory corruption, code injection, and still maintained the high performance deterministic requirements that their embedded system required.
Yeah, and what I would add there too is, one of the awesome things that both RunSafe and Lynx are really focused on is ease of integration, ease of migration and deployment of our capabilities. So for this mutual customer, this wasn't a 6-month, 9-month integration effort and port everything over and add the security and do all these extra steps manually and kind of work through that. And they had to do a little bit of development work, but RunSafe and Lynx are very aligned in our goals of making security and safety easy. And that's where, Lynx is a great partner for us. They have awesome DO 170 safety of flight certification packages and processes, and we kind of fit in with that really well. We've got a good path to doing this security capability in those safety of flight DAL-A, DO 330 TQL1 environments in a way that our customers don't have to manage or worry about it, any more than they would their normal capabilities. And so, this customer, as Patrick said, is getting this, modular, awesome architecture from a systems perspective with great RunSafe protections that they don't have to manage and maintain every release. They can just work their software releases and have the capabilities without burdening their developers. And in fact, that's one of the things I really like about the Lynx ecosystem is you can, a lot of embedded systems, it's tough to do local development for your teams, right? You've got a limited set of physical hardware, and Lynx really makes that easy for developers to iterate quickly and then get it onto production hardware, at the last mile with minimal issues. And so, RunSafe's the same way. You can deploy the protections to your local environment without having to annotate code and work through, a ton of false positives and scam reports and things like that. So, that customer is getting a really awesome capability deployed that's going to set their system up for long-term success.
Okay, that brings us to crystal ball time, gentlemen. So we talked about a lot of stuff today. Keeping all that in mind, where do you see the industry trending in the next 5 to 10 years? Predict the future. We won't hold you to it.
Yeah, that's it's an open topic for sure. I think there's some really interesting trends in AI, and I think nobody on the call here is going to be surprised to see AI as kind of the first up topic here. But there's a lot of really cool research being done in penetration testing and finding vulnerabilities and using AI to assist operators in security. And there's pros and cons to those approaches. Not all of them are great, but there's some really cool stuff being done in those spaces. But one of the things that is a negative that doesn't get talked about often enough is a lot of these new capabilities for helping accelerate development speed are trained on software that's not secure. And so that's really important as we think about, military systems and aerospace systems where, an LLM that was trained on Stack Overflow or a random, source code repository on the internet somewhere might be trained to have a buffer overflow in it, not on purpose, but that code just happened to have it. And so, I think we're going to see a rise in software vulnerabilities over the coming years as more and more developers are using these code assistants to produce faster code that looks good, but may actually have these subtle memory corruption vulnerabilities in them. And so, it's kind of interesting, from my security researcher background to see both progress in finding vulnerabilities with AI and, how can we do that more efficiently and better, produce better results, and seeing that happening while also seeing more bad code be written out of the same technology. I think that's kind of an interesting thing that we're going to see more of in the future. And, who knows where that balance of power is going to end up. Is it going to be for the overall good, or are we going to end up with overall worse code? I think probably for the overall good, but the next 6 months to a year, 2 years might be really rough.
Anything to add? Yep, go ahead.
Oh, and then that's where the mixed criticality systems come into play. As more compute is added to these platforms in the field, there's going to be the need for these additional capabilities, and AI certainly will be one of them. But you're not going to be able to add dedicated compute for each application that you want to run on the platform, and so you're going to have to take advantage of the compute capabilities that you have, today. Oftentimes, that was something that was, from a hardware perspective, certified many years ago when it was developed and first designed. And so, how do you fit that in? And Lynx is taking the approach of with our Lynx Secure hypervisor of enabling those safety-focused or non-critical applications to run alongside, but totally separate from the safety-critical applications and subjects within that same hardware. And so you're able to mitigate that risk with that approach. And so you're able to then take advantage of whether it's new policies or new state actor risks, and apply that in systems that now need to be developed faster and more cost effective for application within the field.
Yeah, and I think one other thought. Sorry, one of the things that I think is really interesting that's been developing over the last year or two is the rise of kind of the disposable weapon system. So we talked about disposable UAVs on the slide here. There's a lot of interest in having lower cost solutions that can still accomplish the mission, but we've got to have balance for that, right? As we strive to cut as much things as we can to bring costs down for these various UAVs, we've got to make sure that we're still doing enough security, enough safety, so that we can accomplish the mission, right? We don't want to end up in a situation where, a UAV flying overhead has a trivial vulnerability that gets exploited, and the drone turns around and bombs, an allied target or something, right? And so, finding that balance is going to be interesting. I think, as with most feedback loops, we're kind of coming down from this trend of really bespoke systems and looking at how can we build things better, faster, cheaper, that we don't care if they survive the mission. We just need them to accomplish the mission. And I think we're going to probably overcorrect a little bit insofar as not doing enough security or not doing enough resilience in architecture and design. And so, in some cases that's works great, right? But in other cases, we're going to need to come back up and do a little bit more security. So I'm really intrigued to see the DoD SWIFT approval process get developed, and see how that's going to play out for system integrators and the government as far as speed to getting updates and new software capabilities into the field, because a core component of that is having good, accurate SBOMs and being able to understand truly what the risk is in your software that you're shipping, and that might help kind of sort that bottom of the feedback loop of going too low, if we know that there's a bunch of vulnerabilities we're shipping in the software.
Thank you, gentlemen. And to the audience, we got our final poll for you. Are you planning cybersecurity upgrades for your embedded systems within the next 12 months? A, yes, we have a specific project already planned or in motion. B, yes, we're in the early planning or budgeting stages. C, maybe it depends on funding or project priorities. And D, no, not in the next 12 months. And E, not sure, still evaluating options. I'll give you about 30 seconds to come up with some answers. It looks like the most popular answer is not sure, still evaluating options. Well, maybe this webcast will help you make that decision. And so this is for Shane. So we have 3 main takeaways from today's discussion. Shane, you want to share what would like the audience to have learned today?
Yeah, absolutely. So, the first thing is aerospace platforms, there's a lot of risk, a lot of threats. And so building in that resilience and kind of safety-focused engineering can really be beneficial. And we want to make sure that those systems are secure, that they have good safety architecture, and that you're getting the most out of your hardware and your systems. And you're going to do that by having a more robust and modular system with security baked in. And the second takeaway is that legacy embedded systems with old code, but even new code today, right? We have customers that are working on code that they're actively developing along with code from the 80s. Those are being connected to more and more systems. And as we look at kind of battlefield management and what that looks like, there's a lot more interconnectivity, not even just between systems inside of one weapon system or one airframe, but now even connecting more and more broadly. And so, that really radically increases the attack surface risk. And we hear in the cyberspace people talk about hardened outsides but really soft insides to architecture. And so we want to make sure that we get everything secured, not just external interfaces. That way you can reduce the risk across the board. And then if you can integrate security when you're doing architecture, when you're doing a tech refresh, and get modular architecture that can be safe and secure and isolated, that's great. And having that runtime protection gives you that extra layer of defense and depth. And having all those things kind of pieced out and modular gives you a great way to achieve and maintain your certification while allowing you to, make changes in the future with minimal change to your certification packages, right? And so that's going to help you get new software, new features, new capabilities onto your platforms faster.
And there were some additional resources for the audience. If you want to, I'm sorry, you want to say something? Go ahead.
Oh, I was just going to add into the key takeaways that you hear a lot about defense in depth and using at least on the commercial and enterprise side, there are hundreds of different tools for security, from very niche to very broad. But with the Lynx and RunSafe partnership, you're able to have that security, have that certification pedigree and that deployment pedigree for being deployed in the field, and pairing that with the RunSafe memory protection, you're able to remove a whole category of exploits that you have to protect against. And so that's what makes this combination so efficient, and still have that defense in depth deployment without having to layer on dozens of things. You're able to really have a much smaller field to defend. So that's
excellent points, gentlemen. And to learn more from our experts, you can find some additional resources here, such as the integrated RunSafe project with Lynx Mosaic RTOS. It's a white paper. And we have the RunSafe Security Safety of Flight approach, a technical paper. And you can schedule a consultation by reaching out to sales at runsafesecurity.com or to Lynx at edge@lynx.com. And now I am ready to start the Q&A. Let's see what we got in the queue. First question. This one's not assigned, so either one of you can grab it. How do we justify spending on cyber if leadership is focused on mission delivery?
Yeah, I'll take that question. I think it's a tricky question, but the way I look at it is if you can do cybersecurity right from the start, or as early as you can, right? I mean, a lot of these systems are already fielded. You're already doing the active development deployments. The sooner you can do that, the faster you're going to be able to mitigate security vulnerabilities, which is going to reduce your time to getting your ATO, reduce your time to getting certification. We talk about like DO 356. And so the more you can do security that's automated and quick and get that done, the faster you're going to be able to get your software deployed, and you're going to be on schedule more often than not. And it also allows you to allocate more resources to your feature development, your bug fixes, your certification work. If you're not having to focus on cybersecurity, you can use those labor hours to do other things. You can use that to reduce cost or to spend in different areas. So that's how we approach it, talking to our customers. And I think that's something that is really of value to the system as a whole, because even if security requirements aren't always perfectly defined, or they can be hard to meet sometimes, it's a lot easier to do the security up front than to have to ask for risk acceptance letters, or slow down your development at the last minute, deployment at the last minute to fix all these security bugs.
Reminds me of what I talked to power systems. People on the ground systems, they put power in at the end instead of designing it from the ground up. So your same thing. You got to have your security from the ground up. Otherwise, it's just a patch.
Yep.
That's what you're saying.
Exactly.
Yeah.
Okay.
And the security requirements, they're not going to go away. They're only going to become harder and evolve faster. And so for customers that have maybe tried to use that as a way to maintain their budget or their timeline by making some of those security requirements optional, it's not going to work anymore. And so you have to, as you said, from the ground up, throughout the development lifecycle, have that focus on security, so that you're able to still maintain your budget and still, because security is not optional.
Next question from the audience. This is unassigned as well. How do you defend quantum plus AI hacking with a software-oriented cybersecurity system? We would like that one.
Yeah, I guess I can take that as well. Sorry, Patrick. Security questions. I think it's no different than anything that we're doing today, right? You've got some set of known vulnerabilities, some set of unknown vulnerabilities. You got to proactively build in security capabilities today And if that's, if you're looking at memory corruption vulnerabilities, quantum isn't really relevant there. But, building in, being proactive about the security defenses you're putting in, adding those layers, using the Lynx kind of isolation capabilities to isolate your software. That all helps. AI hacking is kind of interesting. Depending on how you interpret that, using that for finding vulnerabilities, that's just another type of static code scanning capability or dynamic code analysis capability. So, being judicious on getting those bugs fixed is useful. If you're worried about quantum, making sure you're using post-quantum crypto algorithms, and really being focused on getting things that are not only implemented correctly as far as encrypt and decrypt operations, but timing and side channel attacks as well. But it all comes back to having good defense in depth, being securely configured, having runtime protections against memory corruption vulnerabilities, not deploying software that's got known vulnerabilities in it is, I think, the key thing there.
Anything to add, Patrick?
No, I think you covered it pretty well there. It's
Okay.
be an interesting area to watch. Sure.
Next question. This was actually already claimed by Shane. What is the best way to deal with breaking changes and dependencies? Aside from security, it takes a huge impact on maintenance. This questioner wonders if you know any good way except solid SBOM and avoiding solutions that are known to break API among releases.
Yeah, so that's actually really one of the key reasons why RunSafe built our memory protection capability today. Is oftentimes people are stuck on a certain version of software dependency in their supply chain because there's a breaking change, or it's going to take them time. We talked to a customer in the ag business recently, and it took them 2 years to update one dependency because it was so complex and there were so many breaking changes, and so they sat on a CVSS 10 bug for 2 years because they couldn't just rapidly move to that new version. And so, a key thing for us is being able to allow customers to take existing software, rebuild it with our protections, and get those protections against those known vulnerabilities. So you can mitigate that without having to change that version. Now, as a security practitioner, I'm not ever going to tell you don't patch or don't do the security thing that you can do, but having those runtime protections in place can give you that buffer time you need to move to a newer version that might be broken, that might have breaking changes in it. And so, that's our view of the world, is get you a protection deployed into your ecosystem that allows you to mitigate those vulnerabilities as they get found or get exploited. And that really should even kind of level out your patching process, allow your developers to work in those changes as needed without having a 5-alarm fire every time something gets discovered.
Totally agree with that, and that's why with the Mosaic approach, is having that SBOM as part of the build process with your pipelines, so you're able to shift that awareness left in the process, and then you're able to define those vulnerabilities while you're still developing and work on those on the patches, the remediations on before it's shipped, and so that helps keep that feedback loop really nice and tight, so that you hopefully don't end up with those super complicated dependencies in the first place.
Okay. Next question. I'm going to throw to Patrick first. What are your main focus areas to meet DoD military system requirements now? You want to take that one?
Sure. So right now we're paying close attention to the SWIFT announcement from the DoD, along with the recent change in approach to risk management framework, and how they're bringing automation and AI into that, and how you're able to leverage that, so you have that ability to take the customer platform requirements, program requirements, and align those with those security requirements from the government level around the system as a whole, the platform, and making sure that you're moving at the speed at which the world requires you to do that, so that you're meeting, particularly as you're rolling out these new changes. That's the updates to CMMC, Swift, and the new risk management approach. As those roll out and take shape and go into effect, you're well positioned with security at the foundation to meet those and have that mapping and succeed for the customer and for your platform.
Anything to add, Shane?
I think Patrick covered that really well.
Okay. Next question. Hi, there are airworthiness security process specifications. They need DO326, ED202. What can you say compliance of your solutions to those process? What can you say? I guess what can you say? Did less about that word. What can you say about compliance of your solutions to those process specifications? Would either of you like to take that?
Patrick, that's a compliance question.
Sure.
I can.
So with DO326 and 356, that's a space we're actively working on and watching and ensuring that, in part because of its the cost of attaining those certifications, we're making sure we're able to then to hit that, bring that to market in a cost-effective way for our customers, when they need it. And so that's something we're working very closely towards, around ensuring that both the safety criticality and certification with DO178 and then ultimately DO356 and 26 also arrive with the security certifications.
Okay. I got time for one more question here. How do you manage the single effects on the hardware to get the hardware certified? Either one of you want that one?
I'm not sure I'm tracking that question. Patrick,
They're asking about, as it says, cosmic rays flipping from 0 to 1 on integrated circuits, is what they're talking about. Do you guys deal at Lynx with rad hard single event effects?
With RISC-V, we're seeing an evolution from specifically RISC-V to leveraging more commercial off-the-shelf hardware, in part because on the without humans on the spacecraft, right, your that risk coefficient changes, and so how specifically we account for that's slightly above my capabilities, but that is something that's an area we're watching as that market evolves, and as the commercial hardware evolves as well.
Okay, and that brings us to our time limit today. Sorry, we cannot get to all of your questions. Someone may get back to you after the event with more information. I want to thank Shane and Patrick for speaking today. Great job, gentlemen. And RunSafe Security and Lynx for sponsoring this webcast. This is an Open Systems Media webcast. Our copyrighted may not be recorded used in any way without the express written consent of Open Systems Media. This event will be archived online today at the same URL you used to join today's live session, as well as the URL shown on your screen, and be available for at least 1 year. Look forward to seeing you on future Open Systems Media webcasts. Goodbye and have a great week.